Welcome to another edition of the Exadata Ask Tom office hours. I am your host, Cris Pedregal. Today we answer all your questions about Exadata hardware. Our guests are Gavin Parish and Gurmeet Goindi.
Exadata X8 hardware or any Exadata generation hardware, one key aspect that we have decided or we have aligned ourselves to is to use the server silicon refresh model to determine the cadence of our platforms. What I mean by that. So there are many ways to design systems, right? You have the storage servers that are designed in a particular way. I mean, the storage arrays, the computing proprietary silicon-based platforms like the IBM PCs are designed in a particular way. Our design points with Exadata has always been to use mass market silicon, which the mass market server architectures use, and bring the differentiation on the type of silicon we use and the software integration we have to get the best out of that particular hardware platform. If you see, today's market leader in servers, in server chips is Intel. And for now, we are aligned with the Intel's roadmap. And as soon as Intel comes out with a new silicon, we try to time the release of an Exadata platform as close as possible to their release date. We have been fortunate enough in the last 3 release cycles that we have announced the product on the same day as Intel, give or take, primarily due to the integration we have with our engineering team and the engineering team at Intel. We hope to keep this cadence in future, but you never know what future holds. We also take the same time to refresh not only the compute silicon, but whatever else goes in the platform. We try to get the latest flash, the latest disk drives, the latest networking, latest interact networking at the same point in time, so that our customers can get an integrated upgrade when the compute chip transitions. This allows us, our customers, to stay current. It also allows us to have a clear, defined evolution point of the Exadata hardware family, so you can predict when you will get the next generation Exadata system. Gavin, would you like to add something to that?
Yeah, well, it's something that I've noticed. So I was in charge of hardware for Exalogic and Cloud at Customer. So I've been across a few hardware products, and one of the things that I've noticed coming into this team is and from the outside of all engineered system, it kind of looks like Oracle is just picking up the latest and greatest. And you've said we are cutting edge, not quite bleeding, but cutting edge of all things, and we check all things off as we go through those refreshes. But it was interesting to see, and Gurmeet and I are involved in a lot of engineering discussions, but to see the rigor that the engineering team go through. It may just look from the outside that we're picking up the latest Intel, the latest hard drives, the latest network cards, things like that. But we're not. There's actually a lot of work that goes into verifying that every single component, and I don't know how many thousand components are in this thing, but every single component goes through the rigor and the testing to make sure it's correct for the platform as it releases. So this X8 may look like you've just picked up the latest 14 terabyte heliums and the latest Intel chip, but there's a slew of chips to look at. There's each component within the machine is verified that it is the best running product to reduce risk, and go through all of those aspects that, from an engineered system point of view, checks all those boxes. And that was interesting, seeing that and hearing that from the engineering teams as I'm talking with them about this new generation that we were coming out with at the time, the X8. So I thought that was pretty interesting, seeing that.
Yeah, you mentioned the latest specs that we picked up. just for completeness, would you cover what X8 consists of and where and what our speeds and feeds are with the X8 generation?
So the X8, we picked up the Intel Cascade Lake, and if you have a look at the Cascade Lake family from Intel, there's a range of core counts and clock rates. So the difference between our Exadata X7 and X8, there was no core count increase. I believe the Cascade from Intel had a single SKU that was one higher or two higher core count or something like that. But the one that we chose was 24 cores. So the same as between X7 and X8. There is a slight increase in clock rate. So, a bit of a bump there. But the main driver one of the main drivers was around the spectrum meltdown mitigation. So actually making sure that came in the chip, and we'd no longer have to rely on software to mitigate those bits. So without software, it means that it's faster. So we're getting a bump in performance from that mitigation in silicon. From the storage servers, so this is where a lot of change kind of happened between the generations between X7 and X8, the 16-core Cascade Lake. So if you remember back to the Skylake, for those customers out there that are running X7s, they had the 10-core Skylakes. We're running 16 cores in the storage servers for X8, and that's a fairly significant jump. That's 60% more cores, and we noticed that in performance benchmarking. We've cracked the 6.5 million IOPS, which is pretty incredible. The other kind of change, it's one of those. Well, we should pick up the latest, but make sure it's resilient and is at the enterprise grade that we want with a 14 terabyte helium drives. So again, a fairly decent jump in size. So your high capacity storage servers are now 40% higher capacity. So squeezing more into what we have available, giving you the latest and greatest hardware that's available out there. So that's sorry, just one more thing, and going back to the rigor of engineering. You may notice here that there is no flash bump. The 6.4 terabyte flash that we use, the F640s, was not part of the refresh because.
Okay. So I guess you are going to answer my question.
Okay, well, what was the question?
Yeah. Whenever we move from one generation to the next, there are some components that stay the same, right? Not everything gets replaced. Could you tell us why? Because I think that is one of the things that may not be obvious to everyone.
Yeah. To be honest, it wasn't obvious to me when joining the team. It's like, well, of course you'd pick up the latest and greatest, but being in meetings with the performance team, the stress teams, the lead architects, and hearing that, okay, this particular component this new component that we're testing isn't doing what we want it to do, hasn't got the same performance or the same resilience level. We need to tweak this firmware. We need to have a look at this or that, and wait for a series of bug fixes maybe from the vendor, things like that. So if it's not ready and if it's not as rigorously tested and verified that the team are happy with, and it all comes down to kind of one of the drivers from the head of the team, and it's kind of funny to hear, don't screw it up. We have this platform that is running the core of so many of our leading customers that are running the world in IT. The last thing that we want to do is go early with a particular new product or new component that hasn't been tested as much as we want, or hasn't got the performance that we were looking for, or the bump in performance. So if something is available but it doesn't meet those requirements, performance and resilience and failure rates and all the rigorous testing that they do, then we won't pick it up. And the flash cards were an example of that. You have a look at the difference between the X7 and the X8 extreme flash storage, and yes, there's more cores, but the capacity of flash has remained the same.
There's a question that, have we tested the overhead of running a database with TDE versus not encrypted on X8-2? Yeah, I said, now TDE is an interesting topic because encryption is a bidirectional street, right? You pay an encryption overhead and you pay a decryption overhead. Majority of the encrypted databases have a disproportionate amount of decryption happening compared to the encryption happens, right? You encrypt only while write, but you read the data many times over. So the architecture of Exadata is that we have the decryption done at the storage tier. And like Gavin said, the 60% more cores there in the storage tier really, really helps us with the decryption of this data back. The encryption overhead probably remains the same. We did a benchmark we published like many years ago. It's a couple percentage point, give or take, on your write workloads. But on your read workloads, you should not see, you should see little or no impact on Exadata X8. Compared to what you saw at Exadata X7. We really, really benefit more cores on the storage side, definitely on the read path. One of the key differentiations of Exadata, which shines once again based on the offloading architecture, is we are able to push down tasks that are not relevant to serving a database, like decryption and storage. And more cores there definitely helps. So one thing that Gavin talked about is you're getting a 60% more performance in storage, you're getting 40% more capacity. One thing we have not done with the X8 generation is alter the business model changes. So you pay exactly the same amount what you paid for X7 for X8. And you get this additional bump in performance and capacity as a good, nice addition to what you already have.
Anyway, good.
There was one addition that we have, and this is the bit that I wanted to kind of grill Gurmeet over, considering he was kind of central to this one, and it's the XT server. The extended storage server is a lower cost, much lower cost storage tier that has been introduced with X8. It's compatible with all of the supported generations of Exadata, so you can put it in any of your X4s, 5s, 6s, and 7s. And it provides basically an archival area. We're not talking performance here. We've stripped out the flash, so that's how much we're not talking about performance. It is just an area used for infrequently accessed older, the requirement for regulatory data, the 7-year, the 10-year storage. What bring that about? I see, the cost is great, but is it those customers that are pushing for this, and is that the use case that you were trying to pick up?
It's a great point, Gavin. So, and a lot of our customers were telling us the use cases they used to have for less frequently used data for compliance regulatory reasons. What they'll end up doing is to take this relational data outside a relational database and stick it on a Hadoop store, which was interesting. That it definitely lowered their cost for hosting this data on day one, from my acquisition perspective, but it also increased their overall business process cost. Why do I say so? Now, if you look at any data that has to meet some regulation or compliance requirement, there are also requirements around auditing of access of this data. There are also requirements around how this data gets backed up. There's also requirements around how this data is highly available, or what happens to the multiple copies of the data, or what happens to the encryption and decryption of this data. So since the data is moving between structures in the storage media, you have to reinvent these tasks. You have to reinvent what would be an auditing tool would be, say, in a Hadoop store. So most of our customers said, hey, we really like the cost of this Hadoop store, but what we don't like is the ongoing management cost and management expense that comes with this. And our answer was, hey, if all you're trying to do is limit the cost of storing the data in the relational database and still get all the advantages that a relational database provides and an integrated system like Exadata provides, we might have a solution for you. And that was the driver of the business case of this. And we looked real hard at what drives the cost of our systems. As we talked about high capacity systems, if you see a majority of the cost of the high capacity systems is driven by the amount of flash we have. So if we take out the flash and pass the cost benefits to our customers, that really, really reduces the cost of the server. As you know, this server is almost 1/3 the cost of what a high capacity server is. Now, if you look at the second driver of the cost of Exadata solution is software licensing. Now, if it's a low use data, there might not be a business need for our customers to use offloading features like Smart Scan. So we said, let's make that optional. And that further reduced the cost of running this, or using this particular technology for hosting all your data needs. And the third aspect began, and this is what we were discussing when we started, Gavin, was majority of the data that we have in our system for these purposes is hybrid kernel compressed. So we should enable all our customers to use the capabilities of hybrid kernel compression on this storage type as well. And that drove the third level of cost reduction that our customers can get on this system. In a nutshell, it's a completely integrated Exadata storage server, which is transparent to all database operations. It has a very low acquisition cost from a hardware perspective. It does not incur any software cost for using or storing data on it. If you want, you can do it, but it's optional. At the same time, you extend the compression benefits that you're used to in your current Exadata high capacity or extreme flash storage. So I believe for the use cases our customers have in our mind, this is a win-win solution. And we are already seeing a lot of traction on this. If you remember, I'll tell you one story. We went to this big stock exchange out of United States, and the MD of the stock exchange said, I have 500 Hadoop servers running everything that I have on for this kind of data set. At the same time, when I have to apply a Spectre and Meltdown patch, I have to upgrade 500 servers at the same time, and I still don't have a clear view of whether all these 500 servers are upgraded at the same patch level as I want to be. So that was the fourth lever of advantage. Not only we reduce the acquisition cost, not only we reduce the software cost, not only we give you ultra high compression in an integrated database format, you also benefit from the management cost of the system. I see a question of how do you talk about performance with XT? Now, the primary driver for XT is not performance. The primary driver for XT is to give an integrated solution for all your compliance and regulatory needs for all your data. One way to model that, and Gavin, please feel free to jump in here, is we have enough compute horsepower in our server to exhaust the bandwidth that a 14 or 12-disk drive system will give you. So, and that performance will further get compounded with the hybrid columnar compression benefits you see. So in the data sheet, all we are talking about is a pure disk read and a pure disk write performance metrics. Kevin, you want to add something to that?
So yeah, when talking about, I suppose, people's main concern would be the ingress into. So how do you calculate that I have X number of terabytes to get into this thing overnight because that's the batch load. So just making sure that they're the performance stats that we actually need to provide, as opposed to IOPS. We expect, and correct me if I'm wrong here, but we expect that because this is older, infrequently accessed, it's not going to be a regular occurrence. We've cranked up the compression. We don't have the same performance profile as HC or EF. So we're expecting that this is mainly data going in, the kind of write once, read sometimes. So that 350 gig is the ingest rate. So just making sure that that's the only performance statistic that we need to worry about.
Yeah, it answers the question more or less, but I see documents talking about backup for the XT storage cells, and I don't think that's an appropriate use case. Because we don't support that many IOPS for this
Good
storage.
point.
Right?
So when we talk about backups, the use case for that is local backups. So some of our customers do not want to invoke the whole backup cookbook to go to, say, an external backup device like their domain, which is known to have restore issues. So they want to keep the quick copy of the database. So it's more targeted towards that. If you're using an Oracle integrated solution like Recovery Appliance or ZFS, that's probably not the use case. So I totally agree with you on that. But as you know, some of our customers have like really arcane technology to back up the databases, and they like to keep a local copy for that. So that solves that particular use case.
The DBA from 12 years ago in me says, well, a backup that's stored on the same system as the live isn't really a backup, is it? It's a temporary copy.
Yeah. Very good point. Cool. I'll share one interesting use case I came across, and I think this has a potential too. A lot of our customers who have blobs and cloud kind of data, think about imaging, think about contract documentation, and hence and so forth. Today, they keep the metadata in the database, but the actual data stays stored, it's hosted in HDFS or NFS-based solutions. They kind of work, but when you talk about if these images are related to healthcare, then you have to worry about HIPAA compliance and hence and so forth. If these contracts are financial, then you have to worry about other set of compliance rules. This allows you to keep that data in the database and take one whole layer of management away and take one whole layer of human interaction and making sure all your I's are dotted and T's are crossed away and give you one unified view from the database. Who are pushing the envelope on the use cases of XT Server like they have always done on the things that we have announced prior to this. So it's, in some sense, it's your product, and we learn from you as well of how you best use our technologies. Gavin, back to you.
Yeah, well, I just wanted to jump in there. So from a practical point of view, using the XT, it would just be creating, because bringing in the XT, you bring in an extra disk group, an ASM disk group. So all you need to do is create a table space with the data file sitting in that particular disk group, and you're off and running. So if you want to archive a partition, which you can do online these days, and just start moving those tables into the table space that's sitting on the XT disk group. So that's kind of how simple it is, isn't it? There's no need to, there's no application rewrites, there's no funkiness that needs to be done. It's just purely another DBA task that can be done to set this kind of automatic archiving and even blob storage you were talking before. Blobs, I've forgotten the syntax, but store blob in this particular table space and you're off and running. So that's, yeah, the simplicity there is huge. Okay, I think we've covered that one. We've had 10 years of Exadata here. We're into our 11th. So there's been a lot of growth and, expansion and performance increase over the years. And so I just wanted to show this particular slide to really identify some of the growth that's happened and some of the bumps that you see. You see the CPU cores go through a bit of a jump, and then memory got hit during one of those generations and they got bumped up and things like that. So it's an interesting little map here of where we are. And if you actually look at the dates of release, so starting from V1, September 2008, you'll probably notice that they're very closely aligned to Open World to start with because of those big announcements. But, there's like 12 months, then a bit of a gap, and then, it's kind of settled down to about, I think it's about 16 months, 17 months. So it's great to see, they say that, what is it, history, you can't judge the future on history, but I think in some kind of products you can. And just seeing over time, the regular upgrades, the regular bumps in across the board, with storage and cores and memory. But one of the things I wanted to point out, and I only realized this when I was talking to one of the engineering leads, at about, X5 to X6, let's see if I can get this. So the bump in flash, there was a time where, back here in the early generations, flash was pretty expensive and you didn't get much for it. So this is kind of the tie between the hardware platform that we're talking about today and the software that sits on top of it. So from a hardware point of view, it was expensive, so we didn't provide much. But then as the industry got more into flash and some of the, the big manufacturers got more into producing flash and working on that technology, you see this great increase in the last, X5 to X7 days, where it became cheaper. So we purchased more and we loaded up the machines more because it's fantastic for performance. But it also meant that our engineering team working on the software piece could take more advantage of that flash. The last thing you want to do when you haven't got much is load up temporary tables or temp queries or whatever it is. You want to keep that reserve for the absolute best performing block in the database. How do I make the most out of that particular flash cache? But in this later generation where you may have, depending on your databases, obviously, you may have some spare. So how do we make sure that highest performing storage tier is being used in every single occasion? It's around the 12.2, 18.1, where they started storing temporary blocks in flash, and that doesn't sound particularly smart, except the fact that it's an algorithm that if that temporary block is going to be used again, storing it in flash cache actually makes a lot of sense. Things like that, where now that they have more hardware to play with and more hardware to load up and do things to, we're able to make those changes in the software layer to get even better performance. And that's one of the most outstanding things about this particular product is that really close relationship between software and hardware, and the partnership between, making sure that the software team, they know exactly what's happening on the hardware front and they are prepared for everything that's coming along. And it was only after, talking to this engineering lead and seeing this particular piece in the map that, that 12 change actually made sense to me. Why would you do that? Well, that's exactly why. And I think that's really cool.
Yeah, so going back to my one question that I keep asking and you keep answering, it sounds like you are saying that today we are only talking about hardware. So there's one meta observation that I would like to make. first of all, that we cannot talk in Exadata, we cannot ever talk in isolation about hardware or software, because that's exactly the point, because we are co-designing, co-engineering, co-developing both pieces. Again, today we're talking about hardware, but even if we try, we can't avoid talking about software. And there isn't a clear direction where hardware drives everything in software, as in the software piece is just catching up with the hardware, or vice versa. Both things, there are very interesting innovations in software that are taking advantage of the fact that we understand the hardware and we understand all the layers of the software infrastructure, that are not maybe driven by the fact that there is a faster processor or a better amount or large amount of flash or a new layer of storage, an entirely new layer of storage as we have in some sense, right? So that's, I wanted to highlight that. But the other thing I wanted to ask related to this, and as we're looking at the generations, is we have established already that we don't take everything latest and greatest or fastest or largest automatically. And you gave the main reason: we cannot screw it up, right? So we are going to make things part of a new generation, make components part of a new generation, if and only if we trust them enough that they will maintain the very high standards of reliability and not just performance that Exadata is now known for. Exadata is, in a sense, a mature product, but it's not a stale product, meaning it continues to evolve, it continues to incorporate a lot of innovation, but it does it without ever risking the trust of the people who use it, right, and the organizations that depend on it for critical workloads. So, can you speak of pieces that where we had to go and choose a niche component just to keep up with the rest of the architecture? The point I'm trying to get at is that the architecture is always optimized, right, in some fundamental sense, which is also informing what components we add. In some fundamental sense, part of the invisible value is the careful balancing of all the characteristics of all the pieces that make up the architecture and the software adjusted in sync, right?
It's a good question. One place when we really made that decision, and if you look at the X5, it came out in 2014, we picked up NVMe flash. The next mainstream hardware product or storage product that picked up NVMe flash was in 2017. We were 3 years ahead of every storage vendor because we believed NVMe is the way where the flash industry is headed. And at that time, it was not a mass market product. In some sense, it's still not the mass market product, but it's a perfect example where our software believes, our software team believes that this is the way a database should use flash, and this is where we'll push the industry to go, and hence and so forth. We will push, eventually the industry will meet us where our demands are. And this has been one of very phenomenal changes, and it ties exactly what Gavin was saying, that led us to this whole high density PCI based flash coming through, which opened a lot more use cases for us, including some of them covered by Gavin.
So I was reading something from, I think it was Jenny the other day, GPUs. So we don't use GPUs in a database workload, but they're kind of a hot topic, or have been a hot topic in the last couple of years. And I'm coming out of left field for everybody on the phone. I'm completely out of left field for Gurmeet at the moment. GPUs, do you have an opinion, and it's okay if you don't, on
Perfect.
Why we're not picking up GPUs?
Great question. This is something we have debated for many years. So if I have to summarize this, what GPUs are good at? What GPUs are good at is look at a limited set of data or a repeated set of data and look for patterns in it. So things about, does this thing looks like a car? and you can train a model to look at that, and those computations are done very well inside a GPU. But databases are exactly orthogonal to it. In databases, you're looking at a needle in a haystack. You have a lot of data to process, but very little information. Completely orthogonal to where GPUs are good at. You have very little data, but you need to do a lot of processing on it. And by that nature of compute, GPUs do not make a lot of sense where our industry is today. Maybe in future they will. Maybe in future we will use a lot of algorithms that need to be offloaded. But as of today, we do not see an application in a mainstream database platform like Exadata.
Just wanted to double check that with you, that it's something that people may not see. And I was talking with Cris earlier about the comments of don't screw up. That we've mentioned a few times, and this generation map that you're seeing in front of you isn't the entire story. There's a lot of research and development. There's failed attempts at things. There's a lot of engineering that goes into cutting things out, not just putting things in. Sure. And it's something that if from the outside, you probably wouldn't see that. All you're seeing here is a very fast box that keeps getting faster. And yeah, it's the engineering rigor behind that is ensuring and maintaining that performance and that level of resilience.
And there are a few outstanding questions. So how long we will have OL7 and OL6? Great question. So we picked up OL7 with Exadata 19.1, and it's a mandatory operating system on Exadata X8. So Gavin made a very interesting point. We are on the leading edge of technology, not on the bleeding edge of technology. For us, operating system is a mechanism to deliver value, and we have tight integration with Oracle Linux, and they do very cool stuff with us. But at the end of the day, we are serving the database. So we try to stay on the latest kernel and the oldest distribution possible. The kernel is where the database drives the majority of the value. The kernel is where the OL team really works with us and delivers the wonderful features like ksplice and kexec we are big users of. But the distribution, we try to keep as old as possible so that we can support the most possible plethora of apps, a spectrum of apps. Given that context, we picked up OL7 till it was absolutely necessary for us to move to OL7 because there were third-party apps which were decommissioning support for OL6, and it was difficult to get patches for those apps and hence and so forth. What you can do as a customer. As a customer, we will support the 18.1 release for quite some time. And the 18.x release on Exadata will support OL6. So if you are an OL6 customer, you have applications that do not run on OL7 and you want to keep OL6, you are covered, at least for the near future. But we highly, highly encourage you to go to OL7. OL7 is not new. It's been there for 3 or 4 years by now. But at least if I have to give the release date from X8, from the day X8 was released, you at least have a year, or a little bit more than a year, for getting newer releases on OL6. And after that, you will follow the regular sustenance model of Exadata software releases. So you will have some time to plan that. It's not forced on you, but I will highly encourage to plan that because, as you know, the amount of security patches that are coming right now are at a very steep clip. And as time progresses, those patches and their availability in OL6 will decrease, and OL7 would be the next operating system to go to. As a forcing function, database 19C only runs on OL7. And database 19C is the long-term support release akin to 11.204 of a few years ago. So a lot of our customers will go to database 19c as a precursor on your roadmap, please put Exadata 19 as an upgrade path. Gavin, you want to take the -8-2 question?
-2 is obviously our most popular. It's scalable. It's starting at a relatively small, and I'll say relative against the X8, small number of CPUs, and you can start off with capacity on demand and scale up to, I think we can get up to 19 database servers in a rack. But if you have a look at the architecture of the box itself, the maximum memory you can get in there is 1.5 terabytes. And so 1.5 terabytes across the 48 CPUs, math is, whatever it is, 16 gig per CPU. So if you look at the -8, that's 192 cores, but it starts with 3 terabytes of memory, and you can increase that to 6 terabytes of memory, and that's like 64-to-1 ratio. So if you have a very large database that requires a lot of memory and a scale-up application, so something that can't handle, a scale-out rack database, but a scale-up rack database, that's where the X8-8 comes in. It's kind of niche, and I'm not 100% how many customers are picking up the 8.8s or the -8 variant. The -2 is obviously our biggest area of the market.
I like to add a little bit to that. The -8 versus the -2 is also an interesting sign in communicating what we are about, right? It basically really speaks to the fact that there's nobody else that can do what we do. And so, indeed, the capabilities keep growing and growing and growing. Even if it's a niche, it conveys that we are responsible for delivering this product, because this product really underpins a lot of mission-critical workloads for a lot of organizations. Essentially, if you really start looking, you discover that the economy of most societies depends critically on the Oracle database, and a very substantial portion of that depends critically on Exadata.
Good point. And there are a lot of use cases that still drive an 8-socket workload. Like, think about, like Gavin talked about, scale out versus scale up. Gavin also talked about contiguous memory access, and they're very relevant use cases. ZRA, big data. So Exadata is a foundation technology. So if you look at the systems, we are the foundation technology for ZRA, the autonomous database, the cloud service, and so forth. Glenn, I do not quite understand your question, Gavin or Cris, do you?
It's not really a question. I'm just pointing out that it is a foundation, and if you're just talking in a limited fashion, though, Exadata databases is the only application. Well, actually, it's not. The Exadata is used in another application completely, the recovery appliance, and then big data uses the same hardware in a different way. So I'm just saying
good point. For this talk, it's the Exadata as a product, not Exadata as a foundation. So Exadata as a commercial product we were focusing on. Yes, and you're absolutely spot on that it's the foundation of many things we do in Oracle. Cris, let's just handle the autonomous question. So great point that yes, the new database machines have the autonomous database sticker on it. And what does it mean? So if you listen to what Larry mentioned and what Juan said, our goal is to provide all the autonomous database features that we built for the autonomous database on all Exadata consumption models, whether it be on premises, cloud service, cloud at customer. Of course, the autonomous database cloud service will only be available in cloud and cloud at customer at some point in time. But the core database engine, which runs or enables that, will be available to all Exadata customers Reason being, it's built on Exadata. It's dependent on how Exadata handles things like automatic indexing and things like using in-memory formats and flash cache. That's definitely a topic for us in one of the following office hours. But that has been the enabling Exadata technologies that enables the autonomous data warehouse and autonomous transaction processing. Cris, can you add to that?
Yes, this is very important. I wanted to expand a little bit on a conceptual aspect of this. If you think about autonomous as an asymptote, something that we come closer and closer as we advance in our development of the technology, the important thing that we need to distinguish is there are features in both the hardware and the software of Exadata that enable delivering the autonomous functionality. And the distinction that we need to make is that part of what is required for the full autonomous thing is things that you can only have in the cloud. And the reason is that in the cloud, we can look at what's happening in a number of systems, a large number of systems, and we have a different level of control than what we, by we I mean Oracle operations and development, right? Than we have on an Exadata that is running on the premises of the customer, where the customer naturally has control. So I want to make that distinction, that there is a fundamental conceptual difference between the features that enable us to deliver the full autonomous functionality in the cloud context and the full autonomous functionality itself. Those features are available, and to the extent that we can, we make them available and visible to any edition of the Exadata database machine, including the ones that are on premises. But in order to deliver the full thing, we have to control more than what an on-premises Exadata is meant to be controlled by us, by Oracle, right? That's an important distinction. So I just wanted to say that because this comes up and will continue to come up for a long time, I suspect, because it's tricky, right?
Yeah, and significant.
Anyway, we are several minutes past our official end time. This, to me, is excellent news that people have stayed for a few more minutes. It means there is interest in this, and it means it encourages us to do more. Please remember that you can go to the office hours platform for these office hours, and you can add your questions there, and our experts for the session will get them. So that's a way to continue engaging us. And go to our blog. There is an Exadata blog that you can easily find by going to your favorite search engine to find Oracle Exadata blog. Gurmeet is a frequent contributor there. We're going to see more of Gavin soon. So there are several ways in which you can continue our engagement with you. And you can do that over Twitter. You can do that by commenting on the blog. And absolutely, you can do it by posting questions against the sessions for this. So I want to thank Gurmeet and Gavin for helping us articulate some of the things that we think you should know, right? As people who are interested in our technology and the way we do our technology. Thank you. Continue the conversation and ask your questions at the Ask Tom Exadata office hours. This is Cris Pedregal.